All right, we're going to finish up our work on surface area and volume today by looking at some more application questions. These questions are what are going to deal more with multiple step processes and processes where we have to blend maybe a couple different types of our three-dimensional shapes together, like this first example here. All right, so this says a monument outside of City Hall has the dimensions shown. If 1 gallon of paint can cover 259 square feet, how many gallons of paint must be bought in order to paint this monument? Assume the base of the monument cannot be painted, and that paint can only be bought by the gallon. Okay, so what we really have here is a rectangular prism with a pyramid set on top. And the key to this one is to understand we're only going to paint exposed surfaces. All right, so if we look at this, the paintable surfaces of this shape are going to be the 4 rectangle sides and the 4 triangular roof sections. The bottom of this prism, or excuse me, the top of the prism and bottom of the pyramid, those aren't exposed surfaces. Those 2 rectangles are actually, it's a square. Those aren't exposed, just like the bottom isn't exposed. So you only have to paint exposed surfaces, which are going to be the 4 rectangular sides and the 4 triangular roof sections. Okay, so the paintable surfaces, each of these rectangle sides are 9 by 27. So we got 4 9 by 27 rectangles, and we have 4 triangles. Each of these bases of this triangle are 9, and the heights are all 9. So 1/2 times 9 times 9 is the area of 1 triangle, right? 1/2 base times height, and then I got 4 of them. Okay, so now get out go calculator and crunch it up, and we get 972 for our 4 surfaces of our rectangle and 162 for our 4 triangles up top. That's a total of 1,134 square feet. So the paintable surfaces for this monument represents 1,134 square feet. Now our paint covers 259 square feet each. So if 1 gallon of paint can cover 259 square feet, and we have to cover 1,134 square feet, then do the division here, and you get 4.38 roughly. All right. Now it also says that paint can only be bought by the gallon. So in this case, we have to round up and buy 5 gallons of paint, right? 4.38, you just need a little bit more than 4 gallons. You got to buy that fifth gallon in order to be able to paint this whole thing. So you got to buy 5 gallons of paint. Okay, so there's a look at an application question that it also involves kind of a combination of our shapes. Let's look at another one here. So we have a company that manufactures aluminum mailboxes in the shape of a box with a half cylinder on top. The company's going to make 1,938 mailboxes this week. If each mailbox has the dimensions as shown in the figure below, how many square meters of aluminum will be needed to make the mailboxes? Use 3.14 for pi, round your answer up to the nearest square meter. Okay. All right. So what you got here is, again, we got to build this mailbox. So the surfaces you got to look at is you got the front. If I call this the front and the back, you got the 2 sides, and the bottom are all exposed surfaces. The top is not going to be an exposed surface because we're going to cover it up with this half cylinder. Okay. So what we got are 5 rectangular sides and 1 half cylinder on top. Okay. Now, if I look at the cylinder on top, it's a half of a cylinder. The diameter of the cylinder is the same as this dimension of the rectangle. So this 0.2 represents the diameter of this circle if it was complete. Okay. So our radius that we want to use in our formula is 0.1. Okay. So to calculate surface area, I did 0.2 times 0.3. That's the bottom rectangle. And then I did 0.2 times 0.45. That's this face. And I doubled it because this one back here is the same. And then I did 0.3 times 4.5. That's this longer rectangle side. And then I doubled it because there's another one back here. So those are my 5 rectangular sides. And then I got to calculate the surface area of this cylinder, only half of it though. So I just wrote the formula out, 1/2 times the answer to the surface area of a cylinder, which is 2 pi RH plus 2 pi r squared. Okay. All right. So I did some computations, 0.2 times 0.3, 0.06, 0.2 times 0.45 doubled is 0.18. 0.3 times 0.45 doubled is 0.27. Okay, so I got, those are my rectangles so far. And then I loaded in all my information here. So 2 times pi, 3.14, times the radius, 0.1, times the height of the uh, cylinder, which again is the distance between the circles. So this 0.3 represents the height of the cylinder. So 0.3 plus 2 times pi, 3.14, times the radius squared, and 0.01 squared. Okay. Now at this point, you're using a calculator to generate these two, right? So I added my rectangles together to finish that 1.05. That's the surface area of those 5 rectangles. And then I did my first calculation, 2 times 3.14 times 0.1 times 0.3. That gave me this number, 0.1884. And then 0.1 squared times 3.14 times 2 gave me this, 0.0628. Now I want to add these two together in the parenthesis and take half of it. And if I add them together and take half, I get 0.1256. That's half the cylinder. Okay, if this would have been a complete cylinder, then I would have kept this whole answer, but I need half of it because it's only half a cylinder. So there's my total surface area for this mailbox, 1.1756 square meters, or meters squared. Okay, so that's, every mailbox that we build is going to use this much in material to make it. All right. Now they want to make 1,938 of these things. Okay. So I got to take the surface area for each one and multiply it by that number. Now I made a mistake in my final answer here. They wanted us to round up to the nearest meter, not the nest square meter, the nearest square meter. So this should have been 2,279, right? Because 0.3128 isn't enough for another mailbox. So I want to make sure I have enough material to make all the mailboxes. This should have been 2,279, my mistake here, to make this many mailboxes. Okay, so there's another example of a combination of figures in which we have to, calculate, make sure that we're calculating for the parts that are going to apply to the problem, and then finishing our process. Okay, another type of problem we get is, so Lucy carved this solid out of wood and we're supposed to find the volume of it. Okay, so this is kind of an irregular combination of shapes, but let me show you how we typically do this. What we're normally going to do is we're going to cut this thing into shapes that we can handle. So for example, I'm going to look at this part of my drawing. Okay, and if I bring it down here, this is just a rectangular prism with a base of 8 by 3 and a height of 6. So that part of it is just going to be this part. Then I'm going to look at this middle section and I'm going to pull it out. And this is a rectangular prism. Dimension, it's 8 deep. They're all 8 going back. All right. So it's 8. The 7 is across the front and the 4 inches tall. It's showing us right there. So there's my second rectangular prism that I pulled out of this. And then I'm going to cut this last one off and bring it out. And it's also 8 by 3 by 6. So rather than trying to find this whole shape, I'm just going to break it into 3 pieces and find those volumes individually, then put them all together. Okay. So the total volume of this shape is going to be made up from these 3 different shapes that I have here. Okay. So to find the volume of the first one, it's area of the base, 3 times 8 times the height, 6. The volume of the middle one is area of the base, 8 times 7 times the height of 4. And then my last one here, area of the base, 3 times 8 times the height of 6. Okay. Do these calculations individually. I get 144, 224, 144, and that adds up to 512 cubic inches for volume here. Okay. So the best way to do it is to break it into manageable parts that you can find the volumes of easily. Okay. So you get some like that. And then finally, we get this multiple step type question. We'll go through it here. Susan's planning to apply stucco to a building whose dimensions are shown. The front of the building has a window that measures 45 inches by 64. So this window right here is 45 inches by 64. It's got a door that's 4 foot by 7 foot. The left and the right sides of the building have windows that are 16 feet by 3 feet. So this window right here is 16 by 3. And then on the other side, I got one just like it. And the back of the building has no door or window. Okay, assuming the roof, windows, and door do not require stucco, what's the area in square feet that we're going to apply stucco to in this house? Okay, so the way we're going to do it in general is we're going to find the surface area of the 4 outside walls and then subtract the areas for the windows and doors. Okay, now, so the total surface area. Oops, I got this out of order. I want to show you this. Okay, this front window deal. Okay, let me go back a step here. This front window is kind of one we have to look at because its dimensions are in inches, and we're doing this thing in feet. So we got to do a conversion here. All right, so the front window is 45 inches by 64 inches. All right, so what we're going to have to do is to convert 45 inches to feet and 64 inches to feet, we got to divide them both by 12. Every 12 inches is a foot. So 45 divided by 12 will tell us how many feet this represents, and the same with the 64. Okay, now, before I finish my calculation, go back up here and it says don't round any intermediate computations. You give your answer as a whole number. Okay, so I don't want to round these. So when I do my conversions, this first one, 45 divided by 12 is 3.75. That's a terminating decimal, so I can use 3.75. 64 divided by 12, though, is 5.33333 repeating. All right, zero point 0.3 repeating is a third. And since it doesn't want me to round in the middle of the problem, I don't want to round 0.33 repeating. So I'm going to represent it as a third, a fraction. Okay, you've got calculators that'll do all this, so there's no fear in this. All right, so that little conversion had to take place. Now, if I go back up here, I start to look at my total surface area, right? So I did 32 times 8, that's the side. 32 times 8, that's the area of this side, and I doubled it because the other side's just like it. I did 20 times 8, which is the front, and I doubled it because that's the back is just like it. So these calculations here will give me the surface area of the 4 outside walls. Now in here, I'm taking away the windows and doors. So here's my first window. We just worked on that calculation. 3.75 times 5 and a third will give me the area of that window in square feet because I converted it from inches to feet. 4 times 7 is the area of the door. Remember, it was 4 foot by 7 foot. And then the side walls each had a window of 3 feet by 16 feet. Each one had one. So I'm going to do 3 times 16 and double it. Okay, now it's important that you understand that I put this in a grouping symbol because I want to add all this together and then subtract it from this area all at once. Okay, because we're going to subtract out the area of the windows and doors. Okay, so moving on. 32 times 8 times 2, that's 512. 20 times 8 times 2, that's 320. And then I'm going to take away these areas. So when I did 3.75 times 5 and a third in my calculator, it comes out to the number 20. So nice and neat, 20. 4 times 7 is 28. 3 times 16 is 48. Doubled is 96. Okay, so those are all my individual areas. Kind of put it together here. And this is going to give me 832 when I do 512 plus 320. And then these are the windows and doors added up. It adds up to 144 square feet. So the final surface area of the outside walls is going to be 688 square feet once I take away the windows and doors. All right. So it took a little work, but we got 688 square feet. Now, next question. She's going to use stucco that's sold in bags. Each bag has enough stucco to cover 150 square feet. Assume she doesn't have any yet and she can't buy partial bags. How many will she need in order to apply all the stucco? So what we need to do is take our total square footage, we said was 688, and then divide it by 150 because every bag covers 150 square feet. So doing the division, I get 4.586. Now we can't buy 0.586 parts of a bag, right? You got to buy a whole number bags. So 4 bags won't quite do it. I need a little more than a half of another. So we got to buy 5 bags. Okay. If each bag costs $14.50, how much is she going to spend? Well, I'm going to take the 5 bags times $14.50, and Susan's going to spend $72.50 on stucco. Okay. So that's a little process there, but it's nothing we can't handle. Okay. is putting everything together there. So there was our second day of applications. All right. So tonight's homework is going to reflect those style of questions that you just worked at and looked at. Okay. So make sure you're watching the videos carefully, you're writing information down, and then you apply that to what we need to do tonight. Okay. Make sure you're showing work. Okay. I'll let you get at her.